Good morning. Today we are going over math packet number 12, our last math packet of the year. Sandra bought a pizza for her slumber party. Yum. Jamie and Maria together ate 1/4 of it. Louisa and Abby together ate 1/3 of what was left. Chantel and Sammy together ate a half of what was left. Manuela ate 2 slices, and Sandra was left with 2 slices. How many pieces were in the pizza? I saw some of us were thinking making that picture, and they made the picture as a pizza shape. When I do my pictures with word problems, I always it's default from my last school. The way I was teaching it was the bar model, so I always go to the bar model. So you could do it as a circle, you could do it as a bar, it's going to be the same concept. Okay, so if Jamie and Maria together ate 1/4 of our pizza, how do I want to break my pizza up? Into 4s. So I'm going to break it up into 4s. So I know Jamie and Maria ate 1/4 of it. Then it says Louisa and Abby together ate 1/3 of what was left. So what would be 1/3? 1 box, because there are 3 boxes. So I know Louisa and Abby ate that. Then Chantel and Sammy together ate half of what was left. So how much is left? 2 sections, 2 boxes. How much would half be? 1 of those. So Chantel and Sammy ate that. So I only have 1 section left. Manuela ate 2 slices, and Sandra was left with 2 slices. So what do I want to break that box into, James? I have 1 box left. In that box, Manuela ate 2, and Sandra was left with 2. Logan? 4 slices, because 2 of them were for Manuela, 2 of them are for Sandra. Each of my units here, my boxes, they're all the same amount. How many were in our last box? 4. Can we figure out how many were in the other boxes? If they're all the same amount, and then you can figure out how many pieces there were all together. Luciana.
Where did you get the other C?
This is an L. Louisa and Abby, this is a C. Sorry. Okay, so if you're doing it with your actual pizza, you're doing the same concept. You're cutting it into 4 and then saying, okay, this is Jamie and Maria, Louisa and Abby, and then you had Chantel and Sammy. So whether you did it as a circle or you did it as the bar like I did, either way, you're going to be working it out the same way. Our next page. A bird can fly 1/4 of a mile in half a minute. How far can the bird fly in 5 minutes? What I did when I was working with this was I figured out if my answer is going to be in 5 minutes, in whole minutes, I wanted to figure out that half a minute. If he can go 1/4 of a mile in half a minute, how far can he go in 1 minute?
Ooh, 2 miles. No, that's 2 miles. My bad. Half a mile.
How did you get that?
Because if 1/4 of a mile is equivalent to that, 2/4 is equivalent to half.
So a half to go to 1, we doubled it. So a quarter, if we're going to double it, would be a half. So he can go half a mile in 1 minute. Now I want to go up to 5 minutes. So how many miles can we go? Now it's easier. I can count by my halves 5 times, right? Half a mile, mile, mile and a half. You're going to finish it. Figure out how far he can go in 5 minutes. But we want to break it down to that same measurement So we can easily go from 1 to 5. Not so easy to go from half a minute to 5 minutes, but we can go from 1 minute to 5 minutes pretty easy. Okay. Next page is our 5-card challenge. So in our cards this time around, we have 2 9s. So in your equations, you can use the 9 twice. So you can use 9, 9, 10, 3, 7, manipulate them around using your different operations to get a 5 for an answer. Pattern page. First thing we do is we're going to fill in for the first, second, and third figures. And then we have to do the fourth figure. We do not have to go beyond that. So let's fill in what we know. How many yellows are in my first figure? How many yellows are in my first figure? 1 yellow. How many whites are there? How many reds? How many are there altogether? So in my second figure, how many yellows are there? 4. How many whites? 32. How many reds? 64. And how many total? 100. So now I'm going to look at my third figure. How many yellows are there? How many whites are there? 72. How many reds? 144. And how many all together? 225. So this is what we know just from counting the colors on our figures. So you should have this all filled in on your table because this is what we got just from counting it out. Now we're going to look for our patterns. Let's look at our yellows. Anybody see a pattern? How do we go from 1 to 4 to 9? Ask yourself, what has Mrs. Gambino been telling you is her favorite kind of numbers? Nolan?
1 plus 3.
Well, we're not doing, if we did 1 plus 3, we're not doing 2 plus 3. So that is one way to get places, but it's not 3 plus 3. So
Wouldn't it be 345?
does anybody remember what kind of number is my favorite kind of number? Not exponents, squares. I love my square numbers. And when we do our patterns, a lot of times we see squares. 1, 4, 9. What squared equals 1? 1. 1 squared. What squared equals 2? Equals 4? 2 squared. What squared equals 9? Look at what number figure we have here. You take your figure number, you square it, and you get your yellows. Can you figure out what the fourth figure is going to be for yellow?
Yeah.
We're not saying that out loud. Let's look at our reds, because that's our next easier one. What do we notice with 16, 64, 144, 256? Sorry, we stopped. 16, 64, 144, what do you notice? Ethan? Is it doubling?
Tripling.
Think again. What are my favorite kind of numbers? Is 16 a square?
Yes.
What is it a square of?
4.
4 squared. Is 64 a square?
Yeah. 8.
Is 144 a square? Can you figure out that pattern? 4, 8, 12. What are we going to square next? 4, 8, 12. We're increasing by 4s. Okay. Let's look at our total blocks. Thinking about squaring numbers.
It's
We look at 25. Perfect square of what? 5. 100 is a perfect square of what?
10.
225 is a perfect square of what? 15. Is there a pattern there?
Yes.
So the white one isn't quite as noticeable what our pattern is. There is a pattern that has to do with square. Well, it does have to do with squares.
Or we could find it on our own, because if you add up.
That's the other
Yeah, you
thing.
can add
There
it up.
is a pattern to the whites. You may or may not be able to find it, but if you add up the yellow and the red and you subtract it from the total, you'll be given the white. Okay, so if you can figure out the pattern to the white, you can put it down here and tell me what your pattern was that you came up with. And you can double check it by adding them all up for seeing if you get the total, because we know the patterns for the yellow, we know the pattern for the red, and we know the pattern for the total blocks. So you should be able to find that missing one. All right, next page. We need to draw a net and label its sides. So I've been having a lot of people, when they draw the net, they know there are 4 sides going this way, and then there's 2 sides like this. Why is that not a good representation of my net? Aiden?
Because the top, with the top square, it's not like a square, that's like a more rectangle shape.
Mm-hmm.
And the figure has the top of a square, not a rectangle shape.
I hear what you're saying. I'm looking at it a little differently. If I have this for my top sides, is this and this and this, I drew all the same size. They're not all the same size. It's not a cube. So it's this side and this side need to match up with these sides. This side is way too long to match here. Because what's happening is people are saying, okay, 7x plus 10, that I know goes right here. And we get that figured out. But then we're saying all of these are the same size. But are they?
No.
There's 2 different sizes here. So think about your Kleenex box. When you have a rectangular prism, think of our Kleenex box. Isabel, can you grab that Kleenex box and run it up to me real quick? The top and the bottom of our Kleenex box are a different size rectangle than the side here. You can see on the Kleenex box, it's a much bigger and much smaller. This one, they're similar, but we can see down here, they are not the same size. Okay? Just like our Kleenex box, the top and the bottom are a different size than the 2 sides. So when we draw our shape, we should have drawn it this, the short side should have a short side. When we fold it up, they're going to be the same size. So this right here, for our short side and for the top, they're going to be the same size. So we should have drawn this side and this side shorter, and our top and the bottom should be the same size. So you're going to put the 2x plus 3, so I'm going to draw it again up here so it's drawn a little bit better. If I have my top, and then a side, and then I have my bottom. See how they're different sizes? and then the short side and the short side. So now I can see they're not all the same size. This one is going to go here. This one would go here. So what one am I going to put over on this side? Right here.
2x plus 3.
Yeah, 2x plus 3. So now if this is 2x plus 3, what does this have to be? When we fold it up, they have to match up. So if I fold this to this side, what does this side have to be? 2x plus 3. So this side is 2x plus 3. This side is 2x plus 3 because when I fold up my Kleenex box, they match. This side here is that long side of the bottom, not this part. So you have to imagine yourself folding up that box and making sure, hey, if this folds up to this, they're going to be the same size. My top and my bottom are going to be the same size. So I'm going to put the same measurements around those rectangles because the top and the bottom are going to be the same. My two long sides are going to be the same. My two short sides are going to be the same measurements. So when you're writing out your net, think about if it's not a cube, they should not all be the same size. So really think it through. And that's all you have to do. All classes are drawing the net and labeling its sides correctly. So I am looking at your labels. We don't have to worry about surface area or volume. Next page. It is important that we write correct formulas for our volumes. So make sure you're putting correct formulas. For the rectangular prism, it's that length times the width times height. Mr. Schultz has given us two numbers. So you can say that if the base is 5 and the height is 2, what would my width have to be to equal 90 units cubed? For our cube, length times width times height, or you could say side cubed, because all three sides have to be the same measurement. It's a cube, they're squares. So you have to figure out what number, when you multiply it by itself 3 times, will get you 0.216. Triangular prism is length times width times height, but it's that triangle, so we have to divide it by 2. So I'm going to give us two numbers here, a length of 2 and a width of 7. For our pyramid, it's length times width times height divided by 3. So if we have a length of 11 and a height of 10, what would my width be? You want to challenge yourself working with the pi. Our cylinder is pi r squared times the height. We're giving you a height of 18. So you just need to find the radius. For a cone, it's pi r squared height divided by 2. And we're giving you a radius of 7. You need to find the height. And the formula for our sphere is 4/3 times pi times r cubed. All right, and if you didn't write down all of that, you can look back at the video to watch, pause it, and write down your formulas. last page, last page, we have our finding areas. So area of the figure. Our full figure is a triangle. How do we find the area of a triangle?
Wait. Area equals base? Oh, wait,
Base times height divided by 2.
Base times height divided by 2. Base times your height divided by 2. So if they don't give you that full base, you just need to add it together to find that full length. Then we needed the area of our shaded region. Can we easily find the area of the white? Yeah, that's a square. So the area of the white, I need to do my length times the width. Why would I find the area of my white, Ethan?
Because it's the same thing as the shading.
Do we know that for a fact?
Yeah.
Not necessarily. What can we do with the area of the white to be left with the shaded? Yeah, if we take that total area and we subtract out the white, we know for certain we're being left with the shaded. We could make an educated guess that the shaded equals the white, but if we don't know for certain, there's no proof saying that this for sure will be that. Subtract the white away from the triangle, because you might end up with a triangle that it doesn't work the way you were thinking. Okay? So find your full area, find your white area, subtract the white out of it, and you're left with just the shaded. If you're watching this at home, we hope you are well, and we hope to see you soon. Have a wonderful day.